let g of x equal x if x is less than 1. G of x is equal to 3 if x is equal to 1. G of x is equal to 2 minus x squared if x is in between 1 and 2, including 2. And x minus 3 if x is greater than 2. In part A, we want to evaluate each of the following if it exists. In the first one, it says, find the limit of the function g of x when x is approaching 1 from the left. So what we need to do is we need to look at the scenario where x is approaching 1 from the left. So we're going to notice it here in the restriction of the piecewise function. So if we're looking for x approaching 1 from the left, that's going to be applied to when x is less than 1. And if that is the case, then we need to use the function that says g of x is equal to x. So therefore, we want to find the limit as x approaches 1 from the left, now of the function x. So if we plug 1 into x to evaluate the limit, then our answer is going to be 1. Okay, for part 2, we want to find the limit of the function g of x as x is approaching 1. So from the first part, we've already found the limit as x is approaching 1 from the left to be equal to 1. So what we need to do is we need to first find then what is the limit as x approaches 1 from the right. Well, again, we need to look at our restrictions. So we look at our restrictions. Where is it that we are approaching 1 from the right? Well, we don't use the equals because we don't include it where x is equal to 1. We know that the first one is where x was approaching 1 from the left. And if we look here, this is x is greater than 1. So that means it is approaching 1 from the right here. So that means we need to use this function, 2 minus x squared. So let's go ahead and do that. So we're going to put in that function, 2 minus x squared. Now we're going to evaluate that function. So it's going to be 2 minus 1 squared, which is equal to 1. So now what we've determined is that from the first one, we know that the limit as x approaches 1 from the left of g of x is equal to 1. And from this one, in part 2, we know that the limit as x approaches 1 from the right of g of x is also equal to 1. So then what that tells us is that the limit as x approaches 1 of g of x is equal to 1. Okay, in part 3, it's asking us, what is the output when the input is 1? Well, that tells us that when x is equal to 1, then the output is 3. So therefore, part 3, the answer is 3. Okay, in part 4, it's asking us, find the limit of the function g of x when x is approaching 2 from the left. So we need to look at the scenario here when it's approaching 2 from the left. So that's x is less than or equal to 2, so that means it's approaching 2 from the left in that scenario. So that means we need to use 2 minus x squared. So using 2 minus x squared, this becomes the limit as x approaches 2 from the left of 2 minus x squared, which means we evaluate the limit as 2 minus 2 squared. So that is 2 minus 4, which is equal to negative 2. So therefore, as the limit as x is approaching 2 from the left of g of x is going to equal -2. Okay, now for part 5 here, we want to find the limit of g of x when x is approaching 2 from the right. So we need to look at the restriction. So 2 from the right is coming from when x is greater than 2, and that represents this scenario, so we need to use the function x minus 3. So that means we want to find the limit as x is approaching 2 from the right of the function x minus 3. When we evaluate that, we get 2 minus 3, which is equal to, rewrite that again, that is 2 minus 3, and that's equal to -1. So we know that this is going to equal -1. Okay, in part 6, it's asking us to find the limit of g of x as x is approaching 2. Well, looking at 4 and 5, we know that the limit as x is approaching 2 from the left of g of x is equal to -2. And we know that the limit as x is approaching 2 from the right of g of x is -1. They are not equal, so therefore this limit does not exist. So now let's take a look at part B, and part B wants us to sketch the graph of this piecewise function. So the piecewise function has these particular scenarios here. So we're going to go ahead and open up Desmos. And so we know that we want to graph x. So when g of x is equal to x, and then we're going to put in our restriction when x is less than 1. Okay, and then we're going to be able to plot this point when we copy the graph. The next function we're going to put in is 2 minus x squared. And the restriction is the following. We have 1, okay, and then we have that's less than or equal to 2. So there is our other piece. And then we have our last piece here, which is x minus 3. And then that means when x is greater than 2. Okay, so let's go ahead and copy that graph. Okay, so we also need to make sure that we include that point, which is 1, 3. So we have 1, 3. So 1, and 3 is right here. So there's our point 1, 3. We know that our line of x is less than 1. And so that we know we have an open circle here. So this represents x when x is less than 1. And then we have 2 minus x squared. So this is 2 minus x squared when x is in between 1 and 2, but we have to include 2, so that means we have a closed dot here. And then our last function is x minus 2 when x is greater than 2. So that means we have an open circle there. And so therefore, there is our piecewise function. And again, we can confirm our results looking up here.